Hi. Yeah, so let's start with the storing values in an array. So this was like declaration and definition. So we declare that it will be the array will be integer type, okay, and we define that there will be five contiguous memory allocations, okay. So this was definition, and we want to initialize. So here they have given the example int b10. So this is how we can initialize. Okay, we start with curly brackets. So this will go into b0, b1, b2, b3, b4, b5, b6, b7, b8, b9. So from 0 to 9. So okay, so it will be putting all the values. So they have explained the same thing here, the same. And there's one more way of declaring, defining, and initializing an array is not to mention. You don't need to put the size in here. The compiler by itself will be counting the size by the size of this the values that you have put down here. So 1, 2, 3, 4, 5. So by itself it will be putting 5 here, and this will be b0, b1, b2, b3, b4. Okay. And you can also have like this. Here only b0, it will be b0. It initializes all elements by array b to 0. So b0, b1, b2, b till b9, everything will be 0. So here they have given some more examples of the initializations that you can always look into. And this is how you can input the value into an array. We know the for loop, right? And this is I equal to 0, it will be going to I less than 10. That means it will be going till 9, I plus plus, and it might have already declared the marks array. I think they declared it before, right? No, maybe they are using this example here. Their marks, right? Maybe they are doing this example anyway. So yeah, so scene, you know what scene is for, right? With the scene you can take the values from the computer, from the user. So every time, so how it starts, I equal to 0, it will go here, marks, it will replace I with the value of I, so it will be 0. So and it will be asking the user to enter value. So whatever user enters value here, it will go into the marks 0 memory location. Remember, like here, let's say it's marks 0, or we can make. Let me open a new page, just a second. Okay, so just a second. So yes, so okay, so yeah, so let's do how many. It's 9, right? So let's say this is memory, okay, and one, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. And it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and let's say, well, it can be anything. Let's say it's a 2000. Okay, this is the address of the base. This is the base address, and this is marks. Okay, so when we do C in marks I, that's 0. It starts with whatever value user puts, it will go here. Let's say user put 4. Okay, so 4 will be saved here in the memory. Then what happens after saving 4? It goes back. I is incremented. I plus plus, that's I is equal to 1. It checks I is less than 10. I is 1 right now. 1 is less than 10. That's true. So it comes back here. Marks 1. So I equal to 1. So it will put marks 1. So what's the marks 1? Enter user address. Let's say user puts 13. Okay, so 13 goes here. So that's how we can do it. All the values can be put into the arrays. I recommend you to practice this, or just try it once on the Turbo C++. And then it's assigning values. You can also assign the values like this in a program. You can just write mark 3, 0, 1, 2, 3 till 9. You can put and assign any value. And you can also assign from one array to another. Let's say if you have an array first and another array second, you can put the value from array first, all the values of the elements of an array from first to second by this way. Just make sure that the index or the size of both the arrays are same, or if they are not same, just make sure that they don't, it doesn't overflow, else you might end up corrupting the program. Just make sure that it's the same. If you declare an array second, if it's a 25, then first is also 25. Just make sure this. And yeah, I mean, they keep going. They have given some more examples, and the same way you can output the value of an array, right? With the same AI. It's the same way that you can input. So, okay. So let me see. They have given an example. Program that assigns of an array with the square of it. That's crazy. I don't think so that you should have any problem. Actual array this. Okay. So you can always write. It seems that it works. So it shouldn't be a problem. It doesn't seem that it will be having any problems. So yeah, I mean, so here they have some examples over here, which I won't be going through. And yeah, so let's go passing array elements by argument. By argument means in the function argument, okay? In the function, remember, right? So here, it's a function, it's an argument, and it's in text, so it means that the argument will be integer type, and it will be stored in x. Whatever the value will be passed. So here it's using call by value. In the call by value, the value of the argument is copied. Okay, so that's important to know. So let's say let's bin this memory. I like this memory. So let's say, so if you do this, let's say there's a function fun, and you passed mark. Okay, let's say you park mark 1. So what happens is, here mark 1 is 13, right? So here fun will be called. So you remember, for each function a separate memory is allocated. So let's say this fun is called, this function is called, and here if fun mark 1, and let's say the declaration of fun is fun, okay, and int x, okay, and this is also int, let's say, okay, this is the so it means this is the formal argument. So the whatever value is passed will be saved in x. So here what will happen is, whenever, as soon as the function is called, an x integer will be declared, and its value will be copied from here. So it will see, the compiler will see, or the computer will see, the compiler is not the right word right now. Once it's runtime, compiler compiles it, and the system runs it, or computer runs it. So I must say computer. So computer will see the value of will copy the value of mark 1 to the x. So it will see it's 13, so it will copy the value of 13. So now, why I'm putting so much stress on copying, because in later phase you'll find out. I don't want to give it away right now. So what you will see is, since they have copies, now whatever changes you do on this copy will not affect this copy. Later, what we will be doing, we'll be passing an address. So we pass the address. So if you make the changes in this, it will also affect here. So let's not go into it right now. So now whatever you do to the x, value of x, will be affected only here, not here, okay? So that's why we say it's call by value, okay? Because we are copying the value of the argument, or whatever mark 1 is, into the function, okay? So that's the call by value. Passing array. Okay. So this is called by address. We won't be doing, because there's a little bit concept of pointers that they use. I don't want to go through pointers right now. We don't need it. And let's go through this passing entire array as an argument. So here, when we pass an array, we don't pass it by value. Oh, okay. I don't think I want to go through this right now, since we haven't started with the pointers again. So okay, let's skip this thing. It's not very important. Okay, now let's come to two-dimensional array. Okay, so one-dimensional array, we remember it was, so this is one-dimensional array. Right? It's only one dimension. So in the two-dimensional array, this is how we do the two. In the two-dimensional array, it will be like square or rectangle. It depends, like, on the how many elements. So here, if it's a mark, let's not take mark. Let's do B. Okay. So let's say it's a 5. It's a square bracket. Okay. So what do this mean? This is a two-dimensional array. Okay. Yeah, it's a two-dimensional array. So what happens here is like this. If it would happen, let's say 3 and 3, because okay, let's do 3 and 3 because we can see it here. So this is how the two-dimensional array memory is allocated. Okay, this is, and this memory is like this is, how do you find what this memory is? This from here, what's the address of this, the row, what's the address of column? So first we write the address of the row, so it's 0, okay, and the column is 1. So we can see here this, the second dimension is column, first dimension is row. So this is the first dimension, okay. And this is the second dimension. Okay, first dimension is row, second dimension is column. So if you want to access this memory allocation, this is 0 and 0. Okay, if you want to access this memory, so this is 1 and 2. Okay, if you want to access this one, this is 3 and 1. Okay, so that's how we know which memory has what. So this is two-dimensional array. So here you can see, like, if you, so, and this is a common actually. So take look at this in this, like this, these are columns and these are rows. Okay, so 0 0 is the top left one, then 0 1 0 2 0 3 1 0, because there's a second row, that's a 1, that's the second row 1, and this is the first column, so 1 0 1 1. So that's how we do it, and this is how we declare. This is a declaration type, array name, size of dimension 1, size of dimension 2. So okay, so what's the size of dimension 1 here? What's the size of dimension 1? That's dimension 1 is there. The 1 2 3 4. That's a 4. So here we have written table 4, right? And what's the size of dimension 2? That this is dimension 1 2 3 4. So they have written 4 here. So this is how they declare it. And this is how they access. So in the access they put the two for loops. Okay, because for each, so first for loop is for the row, first for loop is for the column. No, they have used it for the, I mean you can use it for anything, but the first for loop they have used for the row, so that's okay too. So first for loop is for the row, you can see we are using I here, and the second for loop is for the column. So we can see for the first I is 0, and this is less than 4, then it jumps here, then the for j equal to 0 it comes here, then table I is 0 0 0, so it goes here first. Okay, so it takes that value in the function, okay, the process, and then it goes back, then j increment 1, then I is 0 and 1, 0 and 1 is this one, then it's I is 0 and j gets 2, 0 2 0 3, as 0 3 j becomes 4, it comes out of this loop, goes here, I is incremented 1, and I is then here, checks that it is less than 4, that's true, then I is 1, comes back here, 1 0, then goes 1 0 1 1. This is how the second dimension starts. And here again this is how we initialize it, 0 0 0. You can initialize by one like this way. There are many different ways of initializing. This is, you're initializing one whole row at a time, just one row, then you start with this as this first curly bracket, then start with curly bracket, this for row 1 2 3 4. Okay, and again the same input value you put, your sign values is the same, even for the output values it's the same.